So we are starting the miscellaneous exercises, and this is the first one. We have to evaluate this. That means we have to simplify this complex number and express it in standard form. So we start the calculation with the complex number, and immediately we split I to the power 18 into these two parts, I to the power 16 times I square, because 16 plus 2 is 18. And what is I to the power 16? We know that I to the power 4 is 1, and this is the fourth power of I. So that means this is also 1, and I square is minus 1. What do we do with 1 divided by I? It equals minus I. How? If you multiply and divide by I, so you then get I in the numerator, and the denominator is I square. I square is minus 1. So that's how you get minus I. So we are looking at the 25th power of minus I. Because 25 is odd, so a minus comes outside. And 25 can of course be written like 24 plus, written as 24 plus 1. So that way you get I to the power 24 times I. Now, just like I to the power 16 is equal to 1, so is I to the power 24, because it is the 6th power of I to the power 4. So that's how you have I here. And because there is 3 outside in the exponent, which is odd, so minus comes out. And inside you then have 1 plus I. Now if you want, you can expand 1 plus I whole cube using your cubic formula. But I think this one will be better and will give you result faster. So next we expand this square, which becomes 1 square plus 2 times 1 times I plus I square. Now I square is minus 1 and 1 square is 1. So after cancelling them, you are left with 2I. And then if you do the multiplication, you get minus 2I times 1, that is minus 2I, and minus 2I times I, that is minus 2I square. Because I square is minus 1, this becomes plus 2. So this is your complex number in its standard form, 2 minus 2I. The next one, number 2, is general in nature. Here we have any two complex numbers, z1 and z2. We then have to prove that the real part of their product, z1, z2, equals the real part of z1 times real part of z2 minus imaginary part of z1 times imaginary part of z2. It looks complicated at first because of this notation REIM, but actually it's very easy. So let's see the solution. So we start the solution with the standard forms of the complex numbers. Let z1 be a plus ib and z2 be c plus id, where a, b, c and d are real numbers. Then we just simply calculate z1, z2. So it is a plus ib times c plus id. If we do the multiplication, we are going to get ac plus aid plus ib times c plus I square bt. Now I square is minus 1, so you are getting ac minus bt, and these two terms have I in them. So you take the I common out and you have AD plus BC. So AC minus BD plus AD plus BC times I. Where the important thing to note here is that this and this are real numbers. So that means this is the standard form of this product Z1, Z2. And that is why the real part of Z1, Z2 is this, the part that is not with I. AC minus BD. What is A? A is the real part of Z1. C is the real part of Z2. B is the imaginary part of Z1 and D is the imaginary part of Z2. So that's how you get your identity. So this next one is about reducing this complex number to the standard form. This hopeless problem does not give you relief at any point. You will realize why I say so when you see the solution. So obviously the solution is all about simplifying this complex number. So you have to write the complex number here, which I did not do. And then you first take this part because it has a minus. So you write 1 minus 4i times 1 plus I in the denominator, and then you know how to adjust the numerator. This will get multiplied with 1 and this will get multiplied with minus 2. Okay, and this part we are keeping it as it is for now, and then we do whatever comes after that, whatever needs to be done. 1 plus I times minus 2 plus 8i, and we do the multiplication here. There is of course no point me explaining everything. So after you go through the process of simplifying this part, and then again you do these multiplications, and the values have not been chosen carefully, so it just becomes more and more complicated. So as you do the multiplication in the numerator, you get this 33 plus 31i, and the denominator becomes 28 minus 10i. And then you know what to do next. You have to multiply and divide by the conjugate of the denominator, so that you can make the denominator real. Okay, so in the next step we do just that. We multiply and divide by the conjugate of the denominator, which is 28 plus 10i. And then after doing all the necessary calculations, there is a cancellation of the factor 2 at the last step. This is what you get. So it looks quite ugly, but it is what it is. Maybe the purpose of this problem is to show you how mathematics really looks. Usually the problems that are given to you at this level are cherry picked. Okay, they have been carefully chosen to give you nice results. That is not the norm, that is the exception. When you see mathematics in its real form, it is actually messy, ugly, and difficult to work with like this. But anyway, let me just end the video with this, and there are other problems also which come after this that we will solve next week. So see you next week with more miscellaneous exercises and their solutions. Until then, this is me, Lucifer from A Mathematical Room. Have a nice day.